so I start adding the sulfur. With excess sodium hydroxide, the sulfur reacts to produce mostly sodium sulfide, but it will also make some polysulfides. The polysulfides have the general formula Na2SX, where it can have anywhere from 2 to 5 sulfur groups. However, because I have such a large excess of sodium hydroxide, I imagine the polysulfides that do form are the shorter ones, with at most around 2 or 3 sulfurs. This reaction requires things to be hot, so in some cases, it's going to need to be heated. In my case, though, the heat that was generated by dissolving the sodium hydroxide was more than enough. The reaction isn't very fast, and it took about an hour to completely dissolve all of the sulfur. On top of this, even when it's done, I need to wait for it to cool down before moving on. In general, sodium sulfide solutions are completely colorless, so this dark red color is coming from the polysulfides. Eventually, it was only warm or slightly hot to the touch, so I took it off the hot plate and transferred it to another container. I could have done things directly in the large flask, but at the end, it would have been a huge pain to clean everything out. In the polysulfide solution, you might notice some black flakes floating around, but this isn't going to affect the reaction in any way, and there's no point in filtering it off. The stirring is turned on again, and then I start to dump in the mercury sulfide. At first, I tried to just dump it in directly, but it led to a lot of splashing. So instead, I had to transfer it in small portions to a piece of paper and then dump it in gently. As more is added, the solution slowly loses its red color and becomes more orange, and we also see some sulfur precipitating out. I eventually finish adding all of my mercury sulfide from both of the waste containers. At this point, there's a whole bunch of mercury sulfide that still hasn't dissolved, so I continue to stir things for about 30 minutes. When I come back, there's still a little bit left, but it's not nearly as much as before. In the liquid, there's a bunch of solid stuff floating around, which is mostly just silica gel and sea light. It's not a big problem though, and it won't really interfere with the reaction. At this point, I think we're ready to get things going, so I dip in some aluminum foil. I decided to start things out slowly, just to get an idea as to how vigorous the reaction is. The foil very quickly turns black, and we start to see some bubbling. If we look closely, we can see that little pieces and flakes are slowly falling off. The process is actually quite slow, but the portion that's in contact with the solution will eventually be completely degraded. Okay, so now that I know the reaction isn't too crazy, I can dump in a little bit more aluminum. When I did this, it initially seemed pretty tame, but eventually it started to take off. My fear was that if I added too much, it could bubble things out of the container, but with aluminum foil, it doesn't seem to be a big issue. Some impatient people have tried using aluminum powder instead, and this definitely leads to a bubbling issue. After reacting for about 10 or 20 minutes, most of the aluminum disappears. From this point on, it's basically just a cycle of the same thing over and over. We add aluminum foil, stir it occasionally and wait for it all to disappear, and then load it up again with more aluminum. Okay, so now to just quickly talk about what's going on here. When the mercury sulfide is added, it reacts with the sodium sulfide to form a water-soluble complex. In the presence of sodium hydroxide and aluminum, the mercury in this complex is reduced back to mercury metal. The sodium sulfide is both regenerated and produced in this reaction, and we also make sodium aluminate and water. A large excess of sodium hydroxide is used here, mostly to prevent the hydrolysis of sodium sulfide and the other polysulfides. If the concentration of sodium hydroxide falls too low, the sodium sulfide will be converted to sodium bisulfide, and the mercury sulfide will not be soluble anymore. Also, The amount of polysulfide solution that we need is hard to calculate because it tends to react with other metals that might be present, like arsenic or antimony. It isn't really an issue for me because I should really only have mercury sulfide here, but it is an issue when people try to purify natural cinnabar. At some point, some crazy spider decided to explore the reaction. He slowly went down and landed on a piece of the aluminum, but then quickly bailed. At first I thought he was a goner and maybe I'm a monster for not trying to save him, but he was able to escape. However, unfortunately, in his desperate scramble to get out, his web broke and he fell back in. As I continue to add more aluminum, the reaction slows down a lot and it becomes black. Aluminum foil is